Download this code from codegive.com, link in the description below. OK, let's delve into the complex issue of private planes and their contribution to climate change. This will be a comprehensive exploration covering the environmental impact, justification for concerns, relevant statistics, and some simplified code examples to illustrate the scale of fuel consumption. The core issue: private aviation and climate change. The core problem is that private jets, compared to commercial airlines or other forms of transportation, have a significantly higher carbon footprint per passenger. This is due to a combination of factors. Lower passenger load. Private jets often fly with only a handful of passengers, or even just one, vastly reducing the efficiency of fuel consumption per person. A commercial flight might carry hundreds of passengers, spreading the environmental impact. Short flights. Private jet usage often involves shorter flights, where a disproportionate amount of fuel is burned during takeoff and landing. These phases of flight are less efficient than cruising altitude. Older technology. While newer private jets are becoming more efficient, a significant portion of the private jet fleet consists of older aircraft with less efficient engines. Frequency of flights. Affluent individuals or corporations using private jets may fly more frequently than the average person, further exacerbating the impact. Production and disposal. The manufacturing and eventual disposal of private jets have environmental impacts through resource extraction, manufacturing processes, and waste generation. Luxury consumption. Private jets are a symbol of high consumption, and their environmental impact highlights the disproportionate impact of wealthy individuals on the planet. 2. Why is this a problem? Global warming. Aviation, in general, contributes to global warming through the emission of greenhouse gases, GHGs, primarily carbon dioxide, CO2. Private aviation significantly adds to this impact. Air pollution. Jet engines emit other pollutants, such as nitrogen oxides, NOx, particulate matter, PM, and sulfur oxides, SOx. These pollutants contribute to air pollution, which can have negative health impacts, particularly in areas near airports. Contrail formation. Aircraft contrails, condensation trails, can trap heat in the atmosphere, contributing to climate warming. The impact of contrails is still an area of active research, but it's believed to be significant. Equity and justice. The environmental impacts of private aviation are disproportionately borne by the global population, including those who cannot afford private jets and those in developing countries who are more vulnerable to climate change. It raises ethical questions about the fairness of burden distribution. Obstacle to climate goals. To achieve global climate targets, example limiting warming to 1.5 degrees Celsius or 2 degrees Celsius above pre-industrial levels, all sectors must reduce emissions. The growth of private aviation poses a challenge to these goals. 3. Statistics and quantifiable impacts. It's difficult to obtain precise, up-to-the-minute data on private aviation's exact contribution to climate change due to data limitations. However, we can provide estimates based on available research and reports. Carbon footprint comparison. A single private jet flight can generate several tons of CO2. Some studies suggest that private jet passengers can have a carbon footprint 5 to 14 times higher than commercial passengers on the same route. Growth of private aviation. The private aviation market has been growing rapidly in recent years. This trend means the environmental impact will likely increase if mitigation measures are not implemented. The COVID-19 pandemic initially saw a drop in overall air travel, but private aviation rebounded faster, with some sectors experiencing significant growth. Asterisk fuel consumption asterisk a typical private jet might consume hundreds of gallons of jet fuel per hour. A long-range jet can consume thousands of gallons on a single flight. Asterisk contribution to overall aviation emissions asterisk while private aviation represents a relatively small percentage of overall aviation activity, its carbon footprint is disproportionately large due to the factors mentioned above, low passenger loads, etc. Estimates vary, but some suggest that private aviation could account for several percent of total aviation emissions. 4. Code examples, simulating fuel consumption. These code examples are simplified and illustrative, not meant for precise scientific calculations. They use Python and demonstrate how to calculate fuel consumption and carbon emissions. Example 1, Fuel consumption calculation. Example 2, Code 2 emissions calculation. Example 3, comparing private jet versus commercial flight. Important considerations for the code examples asterisk. Asterisk simplification asterisk these models are highly simplified. Real-world fuel consumption and emissions depend on many factors, including aircraft type, engine efficiency, flight altitude, wind conditions, and more. Asterisk emission factors asterisk the Code 2 emission factor for jet fuel can vary slightly depending on the source. The value used, 2.52 kg Code 2/liter, is a common approximation. Asterisk other GHGs asterisk these examples only focus on Code 2 emissions. Other greenhouse gases, example methane, nitrous oxide, are also emitted during fuel combustion, and their impact needs to be considered in a comprehensive analysis. Asterisk contrails asterisk the code does not account for the climate impact of contrails, which is complex to model and still subject to scientific research. Asterisk life cycle assessment asterisk a full life cycle assessment, LCA, would consider the environmental impacts of aircraft manufacturing, maintenance, and disposal, not just the emissions from flight operations. Possible solutions and mitigation strategies. There are several approaches to mitigate the environmental impact of private aviation. Asterisk sustainable aviation fuel, SAF SAF is produced from sustainable sources, example algae, waste biomass, and can reduce Code 2 emissions compared to conventional jet fuel. However, SAF is currently more expensive and not widely available. Asterisk carbon offsetting asterisk individuals and companies can purchase carbon offsets to compensate for their emissions. However, the quality and effectiveness of carbon offset projects can vary, and carbon offsetting should not be seen as a substitute for reducing emissions at the source. Asterisk fleet modernization asterisk replacing older, less efficient private jets with newer models that incorporate advanced engine technology and aerodynamic improvements can reduce fuel consumption. Asterisk operational efficiency asterisk optimizing flight routes and altitudes to minimize fuel burn can help reduce emissions. Asterisk electrification and hydrogen asterisk electric and hydrogen powered aircraft are being developed for short-range flights, but their application to private aviation is still in the early stages. Asterisk regulations and taxes asterisk governments could implement regulations to encourage the use of SAF, impose carbon taxes on aviation fuel, or restrict the use of private jets in certain areas. Asterisk behavioral changes asterisk encouraging individuals and corporations to consider the environmental impact of their travel choices and to opt for more sustainable alternatives, example commercial flights, high-speed rail, can help reduce demand for private aviation. Asterisk technology and innovation asterisk investing in research and development of more efficient aircraft technologies, including electric, hydrogen, and hybrid electric propulsion systems. Asterisk transparency and reporting asterisk improving the availability of data on private aviation emissions to enable better monitoring and accountability. 6. Ethical considerations. The debate surrounding private aviation and climate change often intersects with ethical considerations. Luxury emissions. Some argue that private jet travel is an example of luxury emissions, where the environmental impact is driven by discretionary consumption rather than essential needs. Social responsibility. There is a growing expectation that wealthy individuals and corporations should take greater responsibility for their environmental footprint and contribute to solutions. Environmental justice. The impacts of climate change are disproportionately felt by vulnerable populations, raising questions about the fairness of allowing a privileged few to contribute significantly to the problem. 7. Conclusion. Private aviation is undeniably contributing to the climate problem due to its high carbon footprint per passenger. While it represents a smaller percentage of overall aviation, its disproportionate impact raises serious concerns. Solutions require a combination of technological advancements, policy interventions, behavioral changes, and a deeper consideration of ethical responsibilities. The future of aviation must be sustainable to meet global climate goals and ensure a more equitable distribution of environmental burdens. It's crucial to stay informed and advocate for policies that promote sustainable aviation practices. The code examples provided offer a basic understanding of fuel consumption and emissions calculations, but remember that real-world scenarios are far more complex and require comprehensive analysis.